I would like to move on to signaling circuits. Let it be an audio amplifier. Let it be an audio amplifier. Audio voltage may be zero point 3 volts, 300 millivolt. That may be moving like this. With respect to time, from frequency 20 hertz to 20,000 hertz. This is the signal obtained from a microphone. It has only 300 millivolt only, not more than that. But if you ask me, the current capacity of this signal obtained from a microphone may not be very, very high. Current capacity is very, very small. That is, the power of the signal is very, very small. Therefore, if we connect this to a low resistance, it is not able to supply that much current. When you draw the current from the signal source, the voltage 0.3 volts may become 0.1 volt. The signal may become, in amplitude, it may become 0.1 volt. Always the signal is referred as 0.3 volts PP. Peak to peak of the signal, normally. Here, of course, I have mentioned here RMS voltage. Peak to peak means let it be 0.6 volt PP. Therefore, when you apply it to a load, the load may be drawing some current. Ultimately, the voltage will come down. We are not supposed to bring down the amplitude of the signal obtained from a microphone. Then what will happen? With the lesser voltage, and when it is applied to a real amplifier, the signal may be too much distorted. Therefore, when you apply a signal, it should not be overloaded, and then you may have a voltage amplifier, and you may have a power amplifier, and then maybe a speaker. Therefore, the first amplifier which is fed with the signal should not draw any current. What is the meaning? You should take the signal, it should not draw any current. Therefore, internal impedance of the first stage is supposed to be very, very high. Internal impedance of the voltage amplifier is supposed to be very high. Then only 0.6 peak to peak will not come down. It will not create any effect. That's why always we are more bothered about internal impedance of the first stage to which the signal is being fed. Like that, internal impedance is taking very. I was referring to applying a microphone signal to a voltage amplifier, like that. Okay, fine. But here, in every circuit, the circuit may be designed with transistors. Transistor with the incoming signal is being fed to the base of the circuit. Like that, here only we are telling impedance of this circuit will be very important thing in the design. Therefore, this amplitude should not be brought down. Therefore, what I want to say is, if this is going to be the first stage of this, the whole first stage of the series of circuits, series of transistors, this is not supposed to draw current at all. Therefore, the internal impedance of this stage should be very high. Transistor means moderate. Transistor means impedance is moderate. Therefore, they have, when in the RF circuits and all, when the signal obtained from antenna in communication system is going to be very, very small. Therefore, the first stage is the RF amplifier. That RF amplifier is supposed to have very high input impedance. Therefore, the first stage of the RF amplifier in communication circuits will be made of not the transistor. Instead, they will be using FET, field effect transistors. These field effect transistors are having very high input impedance. As they are having very high input impedance, this signal cannot be brought down because of the input impedance. Therefore, any communication equipment, the first stage in the RF amplifier will have an FET circuit only. And that's why in audio amplifier also, wherever you have audio signal to be amplified, The first stage will be voltage amplifier. Voltage in the sense, the low signal will be amplified to higher level. After amplification, the sufficient current capacity will be given to that amplifier. That is called power amplifier. Therefore, audio amplifier will have first voltage amplifier and the next the power amplifier. Like that, every circuit is supposed to have a very high input impedance where a low signal with lesser power capability should be fed. Next, coming to, previously I said there is going to be a voltmeter. Voltmeter has got a input impedance, but input impedance may not be very high with ordinary meters. Therefore, they made some 50 years back, there was a voltmeter called, for information, there was a voltmeter called VTVM. That is, this had very before usage of the FET and other things. They were using only VTVM for measurement of the signals, maybe the input signal and amplified signal, because they don't want to load the signal. Therefore, VTVM was a very important equipment which was used for measuring the signal's amplitude. The expansion for VTM is vacuum tube voltmeter. Sorry. Vacuum tube voltmeter. Vacuum tube means the first stage will be like this. There may be a control grid, cathode, anode. This is a vacuum. There is no connection between the control grid and anode or cathode. Completely vacuum. They are not touching it at all. There is no junction like a transistor. Therefore, junction like a transistor means there is an impedance. But if the grid is not at all touching the cathode or anode, the impedance is going to be infinity. If the input is infinity, this grid will not draw any current from the signal at all. Therefore, simply it may be amplifying, it may be processing to apply to a real voltmeter where the exact voltage can be measured. That is called vacuum tube voltmeter, VTVM. Therefore, my dear friends, I have clearly told that the phrase, that is the internal impedance is very important subject for electrical and electronic students. When they are designing the circuits, they have to take into account this only. So one more thing, in fact, you can understand this. That is, in cell phone batteries and all, the meaning, people used to say that the battery has completely discharged. Battery has been completely charged. As I said in the beginning, I forgot to tell you, there may be 3.7 volt battery that may have plus and minus. Battery is completely discharged means, as I said, every battery has got an internal impedance. This is a load. This is a cell phone circuits. This battery has got an internal impedance. When it is completely charged, this resistance is 0. When it is discharging after 2 hours, 5 hours the service, this raises to some value, let it be 36 ohms. That is why when it is completely discharging to 0 level from 100% in a cellular phone, the performance is not good. We have to recharge it. If we start recharging, what we are doing is, we are just bringing this 36 ohm to 0. Therefore, please understand, charging of the battery and discharging of the battery is simply doing the changing of the internal impedance of that battery. That's all. Discharged condition means internal impedance is very high. Charged condition means very low resistance. So like that, it's a very important circuit. Even for now, you know that a lot of batteries being used in UPS. Lot of batteries are being used for car, motor, electrical vehicle is going to come. Therefore, this internal impedance should be taken into account properly, and engineers should understand that. That's why this topic we thought, the Ram's Academy thought this should be discussed for the benefit of the students. Thank you, my dear students. Thank you very much. Let us see in the next.